Hi everyone, Miss Craig here. We're on to lesson 1 for the week of May 4th through 8th. I hope you are all doing well. We'll be working with proportional relationships, and this is our Learn About It video. So first thing, just to kind of review what a proportional equation is, which we worked with in our lessons from last week, is that we are comparing two or more ratios. Remember from last week, we can either compare two pairs of corresponding parts of similar shapes, or we could compare two parts of one shape to corresponding parts of another shape. So if we look at our similar triangles, we could either compare the corresponding sides, so A and C are corresponding, and then we have to go back so that we are in the same, start with the same triangle. So then we could have compared B and D. Or we could have stayed within the same triangle. We could have done A to B from the little triangle, keeping that same order of corresponding parts, C to D in the large triangle. An indirect measurement is any method that either uses a formula, similar figures, or proportions to measure an object. So think about last week's lessons when we were working with similar polygons and then onto just similar triangles when we were setting up our proportions, and then we were setting up our proportions, we substituted in our values, and then we used cross multiplication and we wrote and we solved an equation. So in example 1, we have these two similar triangles. We're going to use what we know about a person's height and compare to a flagpole's height. And we want to see what the height of the flagpole is by using those relationships. So the first thing you might notice is that everything is written in feet and inches. So the first thing we're going to do is we are going to convert everything into just inches. So if we start with the man who's 5'9", and we want to change that into inches, we would take 5 feet times 12 inches plus the 9 extra inches, and that would give us 69 inches. So we're going to think of this as 69 inches. If we take the length of his shadow, which was 7 feet 8 inches, we could think of that as 7 feet times 12 inches in a foot plus 8 extra inches, and that will give us a total of 92 inches. So we can think of this shadow as 92 inches. And then we could do the same thing with the flagpole. So we could take 38 feet 4 inches, which would be equal to 38 feet times 12 inches in a foot, plus the 4 extra inches. And if we do that math, we get 460 inches. So the flagpole's shadow, we could think of 460 inches. So now we're just going to go ahead and we're going to set up our proportion. So we could start with the height of the man, which is BC, to the height of the flagpole, which is HG. And then we could go back to, we want to start with the man again, that his shadow is AB, which means then we would do the shadow of the flagpole, which is FG. So now we could substitute in our values. So BC is 69 inches, HG is H, AB is 92 inches, and FG is 460 inches. We would do our cross multiplying in order to solve. So we would multiply 69 times 460. So we would take 69 times 460. Oops. And that would give us 31,740. 92 times h is just 92h. Solve for h by doing our inverse operation. So divide both sides by 92. And we would get h would be equal to 345 inches. So the height of the flagpole would be 345 inches. Next example, same kind of thing. We're going to compare our height of a man and his shadow, and then use that similar relationship to find the height of a flagpole. So again, step one, we're going to change everything into inches. If we start with the height of the man, who is 5 foot 6 inches, 5 feet times 12 inches in a foot plus 6 gives us 66 inches. We can replace this with 66 inches. If we go to a shadow, 5 feet is just 5 times 12, which is 60 inches. And then if we look at the shadow of the flagpole, 14 feet, 2 inches, we'd have 14 times 12 plus the 2 extra inches, which would give us 170 inches. Now I'm going to go ahead and fill in X for the height of my flagpole, just to kind of simplify the letters. So we're going to set up our proportions. Again, we could start with the height of the man, which is GH, to his shadow, to the height of the flagpole, which is LM. We could then do the shadow of the man, which is JH, compared to the shadow of the flagpole, which is NM. Now we can fill in our values. So GH is 66 inches. LM we don't know, so we're going to use X. The man's shadow is 60. The flagpole's shadow, which is 170 inches. We're going to use our cross multiplying in order to solve. So we're going to take our 66 times 170, which gives us 4,620, equal to 60 times x is 60x. So to solve for x, we do our inverse, so divide both sides by 60. And we're going to get that x is equal to 187, and now that is in inches. So the height of my flagpole would be 187 inches. The next steps, there is another video on the Learn About It, so make sure you watch that video also. And when you're done, you'll go on to the Try It section. There'll be more videos and practice problems to do. Make sure you check your answers. If you're in my class, there's an additional activity for us to do. Everyone, take care, stay well, and we will talk soon.